All right, well, welcome to chapter 12. This is so exciting. You guys are going to get to learn about a new function called an inverse variation, and you're going to get to graph things that are no longer straight lines. So we're moving up in the world. This is exciting. Okay, so a relationship, let's get some vocab out of the way. A relationship that can be written of the form y equals k divided by x is an inverse variation. Inverse variation as long as k is a non-zero constant, so that just means it's a number other than zero. So k could be 1, 2, 3, 4, 5, negative 10, any of those. And x also cannot equal 0. If you notice, x is in the denominator, so if you have a fraction and you're trying to divide by 0, it is undefined, so that's why these functions, in order for them to exist, we just have to make sure that x does not equal 0. The constant k is what we call the constant of variation. All right, so we are going to be able to take a look at some ordered pairs and tell whether or not the relationship between the x and the y value is representing an inverse variation. So let's just remember, inverse variation is y equals k over x. If you think about that for a second, if you think of that as being y over 1, we can cross multiply, and I'm just giving you a little background on why we're going to check it the way we are. 1 times k is equal to k equals x times y is xy. So when you have an inverse variation, this relationship is true every time, that x times y will equal k, your constant of variation. So that's what we're going to check. We're going to take within each ordered pair the x and y values, we're going to multiply them together and see if we get the same constant of variation for every ordered pair. So in this first example, tell whether or not we have an inverse variation. So 1 times 20 equals 20. That's the constant of variation for that ordered pair. 2 times 10 equals 20. All right, so that's good. We have a constant number so far. 4 times 5 equals 20. This is an inverse variation. Explain, you can say that the constant of variation, k, is equal to 20. I'll know what you mean if you say that. Okay, so here's another ordered pair, another table of values. Let's see if this is representing an inverse variation. All you do is see if x times y equals the same k value for each ordered pair. So 2 times 6 equals 12, so that's our k value. 3 times 9 equals 27. And 6 times 18 equals 108. So you can see that we have 3 different k values for each ordered pair. So that means that, no, this is not a constant of variation. I'm sorry, this is not an inverse variation, and the reason why is there is not no constant of variation. Constant means it has to be the same. We did not get the same number right there. So in the last slide, we showed how you can determine or identify inverse variation. If you have the table of values, does x times y equal the same constant of variation? You also can identify inverse variation by its graph. So let's just take a look at this graph. There's some things I want to point out, so I'm just going to make it bigger. Okay, it's a little blurry, but hopefully you guys can still follow this. We have 3 inverse variation functions in this graph. So first I want to focus on the purple one, y equals negative 2 over x. Every graph will have 2 parts, almost 2 curves. You can see here is this purple one right here, and then in the kitty corner part of the graph is the other one. So if I were to graph y equals negative 2 divided by x, I would have this curve and this curve. Y equals 5 over x, the blue. You can see here's our blue one. It's in a slightly different place because this was 5 divided by x, so you'll get different values. And it pairs up with this blue one opposite it or across from it. Y equals 1 over x is this red one going with this red one right there. So this graph actually has 3 different inverse variation functions on it. So just a couple things to, there we go, to point out. Each graph has 2 parts that are not connected. That's what I was just pointing out. And none of the graphs contain the point 0, 0. If you notice, here's our origin right here. Nothing went through the origin. That point can never be a solution of an inverse variation equation. Remember, the point 0, 0, well, a couple of reasons, but one of them, x would be a 0, and if we had y equals 5 over 0, that's undefined. So we don't have a graph at that point. So now that we know a little bit about our inverse variation functions, let's work on graphing an inverse variation. So what we want to note in this example is right in graph, we are told that it's an inverse variation. We're not asked to determine, is this an inverse? We already know that it is. So that means that our constant will be equal to the x value times the y value. So write in graph the inverse variation in which y equals 2 and x equals 4. So first step is we have to find that k value. So k is going to be equal to the x value times the y value. So we have our constant of variation is 8. Step 2, use that value to write an inverse variation equation. So remember, our inverse variation equation will always have the form y equals k divided by x. So y equals, we just figured out that k is 8 divided by x. All right, so now we are going to come up with a table of values and then plot some points to get our graph. So use the equation to make a table of values. Now we can be strategic about this. We're going to pick some negative values, some positive values. I am going to put 2, 3, 4, 5, 6, 7. I'm going to put 0 in the middle just so we can talk about when x is a 0. But let's pick a few points on the left side. I want to choose points that 8 can divide by those. I don't know how to phrase that. So basically numbers that will fit into 8. So let's see, 8 will divide by a -1. 8 will divide by a -2. I could use -3. And again, all I'm looking at is, I know I'm going to plug these values in for x, so 8 has to divide by those. And to make life easier, I'm just trying to pick values I know that 8 can divide by. 8 does not divide by -3, but it does divide by -4. I'm going to use those same values on the positive side, because if 8 will divide by those negatives, I know it will divide by those positives as well. Okay, so let's fill in our table of values. 8 divided, so here I'll just write a couple of them out. Y equals 8 divided by -4. If x is -4, gives us -2. 8 divided by -2 gives us -4. 8 divided by -1 gives us -8. Now 8 divided by 0, we just always want to be aware of the points on the graph where it is undefined. So 8 does not divide by 0, so we will just say that that is undefined. I'll just put a little note in there. And then 8 divided by 1 is 8, 8 divided by 2 is 4, and 8 divided by 4 is 2. So this table of values just gives us the points we're going to plot on our graph. Let's see, can I make this all fit? So, okay, there we go. So let's just plot some points, and this should take the shape of 2 curves like we saw in the examples. So -4, -2, it's right there. -2, -4. Oops, and then -1, -8 is way down here. Okay. At 0, it's undefined, so when x is a 1, y is a +8, x is a 2, 4, and 4, 2. So we do have to remember that these graphs are going to have curves, and we're not going to cross the x and y axis until we get into a later section, so it just kind of curves down to the x-axis and kind of will end up approaching it and never touching it, and same thing with the y-axis up there. And then Here is our curve on the opposite side. It's just going to kind of fall right up close next to each axis. And there is our graph of our inverse variation. Look how pretty that is. All right, so here's our last slide on the intro video for 12.1. We got this thing called a product rule for inverse variation. It says if x1 and y1 and x2 and y2 are solutions of an inverse variation, so that means that they are ordered pairs on an inverse variation, okay, yep, then x1 times y1 will equal x2 times y2. This is our product rule for inverse variation, that we get to multiply x1 and y1 together and it will equal the product of x2 times y2. So using the product rule, it says let x1 equal 3 and y1 equal 2 and x2 equals 6. Let y vary inversely as x. That just means we have an inverse variation. Find x2. So if this is an inverse variation, then we know that if we multiply x1, which is 3, times y1, which is 2, it should equal x2, which we don't know, times y2, which is 6. This is a true equation. So we can do some simplifying and actually solve for that x2 to find the value that they're looking for. So 3 times 2 is 6 equals x2 times 6. And then to get this x2 alone right here, all we have to do is divide by this number, whatever else we were given here. So we can divide both sides by 6, and we get x2 equals 1. And that answers the question.